Hello everyone, I am Daniele Gregori. I'm a PhD student at the University of Bologna. Let me begin by thanking the organizers for inviting me to give this little talk through video poster. Today I would like to talk about integrability and cycles of deformed n=2 gauge theory, which is the title of a paper by me and my PhD supervisor, Davide Fioravanti. This is the plan of the talk. I will give first an introduction to the former cyber-Witten theory and to the ODE-IM correspondence with two irregular singularities, in particular Liouville ODE-IM. Then I will present our result, which is a new kind of connection between integrability and gauge theory, here for the particular case of pure SU2, the former cyber-Witten theory and the Liouville self-dual model. I will talk about the generalization of this correspondence to other gauge theories and integrable models. And then I will come to the conclusions and future perspectives. The partition function for four-dimensional n=2 super Yang-Mills theories has been obtained through equivariant localization techniques, deforming spacetime through two supergravity parameters, epsilon1 and epsilon2. This is needed for computing instanton contributions. When both parameters go to zero, the logarithm of the partition function reproduces the cyber-Witten prepotential. An intermediate limit, which we will focus on, is the Nekrasov-Chatashvili limit, where epsilon1 is equal to a constant, finite, called Planck constant, and epsilon2 goes to zero. More specifically, having in mind the AGT corresponding to Liouville theory, we may think of it as a quantization or deformation of the quadratic cyber-Witten differential for pure SU2 super Yang-Mills theory, which takes up the form of the Mathieu equation here, where U parameterizes the modular space of vacua and lambda is a scaling parameter. The deformed prepotential may be derived by eliminating U between the two deformed cycle periods, which are integrals of the quantum cyber-Witten differential, which is just the logarithmic derivative of the wave function. We may also consider the asymptotic expansion mode for H going to zero, obtaining thus the perturbative periods or Nekrasov-Chatashvili deformed periods. Alternatively, we can use Maton's formula connecting the Nekrasov-Chatashvili prepotential A and U. Since early 80s, two-dimensional Liouville theory has been recognized as the effective theory of two-dimensional quantum gravity, and it is also an integrable model. In the approach of ODE-IM correspondence, where ODE stands for ordinary differential equation and IM for integrable models, it was discovered by the late Alexei Zamolodchikov that the solution of the following ODE, which is the generalized Mathieu equation, can be used to construct Q, Y, and T functions and functional relation of the Liouville integrable model at Liouville coupling B and Liouville momentum P. With respect to usual ODE-IM with polynomial potential, this equation has two irregular singularities. Thus, its status is interesting also for the development of ODE-IM itself. In ODE-IM, one defines the Q function, for instance, as one of the wave functions with some boundary condition computed at some particular point, typically infinity. ODE-IM is such that all Baxter function and functional relation can be derived by consideration on linear relation among the solution generated by the following discrete symmetries. One can derive in this way the QQ system, the Y system, the Liouville TBA. One can define two dual T function under the Liouville duality B into 1 over B and obtain the TQ Baxter relations, as well as the periodicity relations for T. Let's come to our results. The self-dual for Liouville coupling B equal to 1. Generalized Mathieu equation is just the modified Mathieu equation. This equation can be related to the Mathieu equation, which quantizes the cyber-Witten differential in the Nekrasov-Chatashvili limit by a simple variable change, and this gauge integrability parameters correspondence. I and Davide Fioravanti have found that the two deformed cyber-Witten cycle periods for pure SU2 n equal to supersymmetric gauge theory are connected to the Baxter Q and T function of the Liouville integrable model at the self-dual point by this very simple relation, Q being the exponential of 2 pi I, the dual period, and T equal to twice the cosine of 2 pi, the period. We have proven the first relation for Q analytically by studying the properties of the solution of the Riccati equation, which is just the Seybertwitten quantum differential. Here is some details of the proof. Alexei Zamolodchik proved the relation between the self-dual T and the Floquet index of the material equation, which is this one, T equal to twice the hyperbolic cosine of 2 pi the Floquet. However, it did not recognize that the Floquet is just I times the Nekrasov-Saakashvili deformed Seybertwitten period, since that theory did not yet exist. But we did recognize it, thus establishing another reconnection to gauge theory. The self-dual Liouville QQ relation can be inverted to obtain a TBA for the dual period, being Q just the square root of Y. This TBA enjoys a Z2R symmetry on the moduli space U into minus U, which is nothing but the discrete symmetry used for the ODE-IM construction. The solution of this gauge TBA and that of the Liouville self-dual integrability TBA match perfectly when the parameters are related as imposed by the differential equation correspondence, and thus we verify numerically also the relation between Q and the dual period. The self-dual TQ relation T periodicity relation appear to be non-perturbative exact generalizations of the perturbative Z2R symmetry relation for the periods. The large theta asymptotic expansion of Q infinite gauge U and integrability variables are in terms of the perturbative periods and the local integral motions. But if we take a double limit P going to plus infinity, we get the gauge expansion from the integrability 1, and thus a formula for the perturbative Nekrasov-Saakashvili deformed periods given in terms of the local integral of motion of the self-dual Liouville model, actually of their p square coefficient, where p is the Liouville momentum. From this series, we have obtained a quantum Picard-Fuchs equation at all perturbative orders through an algorithm. Here you see the first two instances. And thus, we can interpret the integrability, the quantum Picard-Fuchs equation that fixes the local integral of motion for the self-dual Liouville model. We have described our gauge integrability correspondence just for the simplest pure SU2 case, but we have evidence that it is much more general validity. For the case of pure SU3, Davide Fioravanti, together with Rubik and Hasmik-Pogosyan, have found a relation between the three periods and the T function of the A2 TODA integrable model. For the case of one massive matter flavor with the gauge group SU2, I, Davide Fioravanti, and Hongfei Shou have found a relation between the two periods and the Y of the integrable perturbed hairpin model. A different kind of connection between Q and Y function and gauge period has been found by Grassi, Gumarino, Hao, and Eske, for instance. However, it turns out that they are different, since they involve different periods generated by the instant-on prepotential rather than by the cycle integrals. In conclusion, the powerful ODE-IM correspondence has been revealing a very suggestive connection between quantum integrable models and epsilon-1 deformed Seybertwitten n equal to supersymmetric gauge theories. The ODE-IM correspondence is a natural quantization scheme for general Seybertwitten theory. It will be also interesting to explore in the future, for instance, the correspondence with higher massive SU2 flavors, 2, 3, and 4 flavors, which is related also to the computation of quasi-normal modes frequencies of black holes merging. Thank you for your attention.